4.4, proving and applying the angle side angle and angle side congruencies. All right, so first we're looking at angle side angle. How many possible triangles can you determine when you're given two angles and the included side of the triangle? Okay, so if we are given two angles and one side, there's only one possible triangle that can be created. Okay, so if we're given two angles and one side, there's only one possible triangle that can be created. All right, try it. What is the relationship between triangle AXB and triangle AYB? Okay, so on this one we are given that this angle A is 25 degrees along with this angle A, and this angle is 45 along with that angle is 45, and then they give us our side measure is 3 and that one's 3. So we are given an angle, a side, and an angle that are congruent. So that means that these two triangles are congruent through angle, side angle. Or through angle, side angle. Okay, next we just have that in writing. So if we are given two angles and one side, we're able to prove congruency through angle, side angle. All right, example 2. Given two triangles with two pairs of angles congruent and one side congruent, prove that the triangles are congruent. So they gave us our two angles that are congruent. So our first angle that's congruent and our second angle that's congruent, and then our side that's congruent. And we want to prove that our two triangles are congruent. Okay, so I know that if I translate M to S, so I would first want to translate. M to S, so I would be shifting this triangle down here. Again, I'm doing my best to sketch this out. Then I would rotate around S. Okay, quickly sketch this. So I would be rotating around S. So that's congruent. Okay, so that's what I would end up with. And then finally, I would want to reflect it across ST. So let's look at our try it. We want to look at a series of transformations that would show that triangle JKL is congruent to MNO. Okay, so we would want to first translate K to N. Again, this is just going to be a rough sketch. translate K to N. Okay, from here I would just need to rotate it so that what I have as L prime will end up on O, so I'm going to rotate it around N. All right, so next we're going to apply the side or angle side angle. A technician installs cables from a cell phone tower to the ground. To pass inspection, both cables must be the same length. Does this installation meet the cable length requirement? And we need to explain. Okay, so we've got our tower with our cables. Let me do this. And our tower is perpendicular to the ground. And they told us we have this 90-degree angle here, which means this also has to be 90 degrees. We know that the tower side is congruent through the reflexive property. So we can use angle side angle to prove congruence. Okay, they're asking us if the cable lengths will be the same. So if I label each of these angles, then we would be able to prove that side AB is congruent to side BC through corresponding parts of congruent triangles are congruent. All right, let's look at the triad. Are JKL and MNO congruent? And we need to explain. All right, so I can see that I have a angle, a side, and an angle, and then an angle, a side, and an angle. So yes, these would be congruent through angle, side, angle. All right, next we're looking at JKL and PQR. Are they congruent? All right, so JKL, we have our side, our angle J, side K, and angle, or side JK, and then angle K. PQR, we have our angle P, and we have our angle Q, but we don't have the side that is between those. So I would need this side PQ in order to prove congruency. All right, so next we're going to look at angle, angle, side. All right, so given that triangle ABC is the triangle determined by angle A, angle B, and the non-included side AC unique. All right, so the first thing we're going to do is we're going to assume that triangle ABC is not unique and that there has to be a triangle that is similar to it. So let me create a triangle. And I'm going to label this DEF. Okay, so angle A would be congruent to angle D. Angle B would be congruent to angle E. And side AC would be congruent to side DF. Okay, so using the triangle angle sum theorem, we know that all of the angles inside of a triangle would add up to 180 degrees.
we can set it up for our missing angle, C. So we would have the measure of angle C would equal 180 degrees minus the measure of angle A minus the measure of angle B. All right, likewise, we could set this up to find the measure of angle F, which would equal 180 degrees minus the measure of angle D minus the measure of angle E. Okay, we know that angle A is congruent to angle D and angle B is congruent to angle E. So I can replace, I can substitute in. Substitute in the measure of angle D and the measure of angle E. Okay, so now this is the same as this. So I know that the measure of angle C has to equal the measure of angle F. So angle C would be congruent to angle F. Okay, so I was just able to prove that angle C is congruent to angle F. So now by angle, side, angle, we can prove that our triangles are congruent. All right, so our assumption is false, and a unique triangle is determined by angle A and angle B and the non-included side AC. All right, let's look at our try it. Using the figures shown, describe a sequence of rigid motions that maps triangle JKL to QRP. All right, so first we would translate, and I would be translating point R down, or point K down onto point R. Again, I'm just going to do my best to sketch this. So that's my congruent angle, my congruent side, or my other congruent angle and my congruent side. So R would equal K prime, this is J prime, and this is L prime. So my first step would be a translation down and to the right. Okay, and then finally I would rotate around R. Right, angle, angle, side. So if I am given two angles and then a side, I would be able to prove congruency. All right, example 5, we want to determine congruency by side, angle, side, 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 angle, side, angle, or angle, angle, side. So my first set of triangles here, I have an angle, a side, and an angle, and I have an angle, a side, and an angle. So I'd be able to prove this by angle, side, angle. Next, I have an angle, and a side, and an angle, and a side. So I would be able to use angle, angle, side. Right, I have side, 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 and side, side, side. So I can use side, side, side. Okay. Next I have side, angle, side. But on this one I have my side and I have my other side, but my angle is in the wrong place. My angle would have to be right here in order to prove by side, angle, side.
try it. What additional information is needed to show that triangle ABC is congruent to DEF by angle side angle? So we have to use angle side angle. And in order to prove this using angle side angle, I'm already given one angle and a side. I would have to be given this next angle. So I'm given an angle and a side, and I would have to be given this angle. Okay, so I would need to be given that angle B is congruent to angle E to use angle side angle. Okay. Go back over here. We want to prove that FH is congruent to JL. So FH is congruent to JL, and we are given that our side is congruent to this side. Our angle, this angle is congruent to that angle, and then this angle is congruent to this angle. So we're given a side, an angle, and an angle, or an angle, and a side. So to prove this, okay, so our first would be all of our given. So one is that GH is congruent to KL, and angle GFH is congruent to angle KJL, and angle FGH is congruent to angle JKL. And those are given. Okay, we are able to prove triangle FGH is congruent to triangle JKL. We're able to do that through angle, angle, side. And we want to prove that FH is congruent to JL. I'm able to prove that now because corresponding parts of congruent triangles are congruent. We already proved that the two triangles are congruent. All right, let's look at the try it B. What additional information is needed to show that angle ABC, or triangle ABC, is congruent to triangle DEF by angle, angle, side? Okay, so now we want to use angle, angle, side. This time, if I wanted to do angle, angle, side, I would need this angle and this angle so that I would have angle, angle, side. So I would need to prove that angle ACB is congruent to angle DFE. Or I could just leave it as angle C is congruent to angle F to simplify it. Example 5. All sides and angles of ABCD are congruent to the corresponding sides and angles of A prime, B prime, C prime, D prime. Is ABCD congruent to the new image? Okay, so a triangle ABC would be congruent to triangle A prime, B prime, C prime, ABC, and that would be through side, angle, side. Triangle ADC would be congruent to triangle A prime, D prime, C prime through side, angle, side. All right, so that means that rigid motion would map ABC onto A prime, B prime, D prime, C prime. So our triangles are congruent, or our figures are congruent. Now let's look at the triad. We are given ABCD is congruent to EFGH. What is the value of X? So we know that side AD would have to be congruent to EH. So I can set my 9 equal to the 2x minus 3 and then solve. Here are my parentheses. Okay, add my 3 over. Divide by 2. So 6 would be x.